The given question is a medium difficulty GMAT data sufficiency question. I'll classify this question somewhere in the 650, closer to the 700 range of questions. It's from the topic rates, focuses on work time efficiency. Missions P, Q and R each can independently produce a product. Which among the three missions is the most efficient? Before we delve into the two statements, let's get clarity on how should the answer to this question look like. If you have to give an answer to this question, the question is which among the three missions is the most efficient. You should finally answer saying that, hey, mission P is the most efficient. Or you could very well say Q or R. Pick one mission and come up with an answer saying that this is the most efficient mission. How will we be able to determine this? If, for example, if you're talking in terms of the time taken, whichever mission takes the least amount of time to complete the task is going to be the most efficient mission. If you're talking about the work done, usually work done is expressed as a reciprocal of the time taken. If mission P takes 10 hours to complete the task, we'll say it does 1/10 of the task every hour. So if you're talking in terms of work done, where the variables, the unknowns here represent the time taken by each of these missions to complete the task, we need to find out which among these three values, 1 upon Q, 1 upon R, 1 upon P, which is the largest of the three numbers. So if it's time, the least value. If it is a fraction of work done, whichever is the largest value. If from the two statements, we are able to come up with one of these two information. If you come up with one, obviously you come up with the other. So if you're able to determine that, then we have an answer to the question. Let's start with statement 1. Statement 1 tells us the time taken when the three missions work together to produce one standard batch of the product. Whatever this number is, 6 hours, 40 minutes. Let's convert this 40 minutes into hours so that we have one uniform unit of time. 40 minutes is 40 upon 60 hours, which is equal to 2/3 of an hour. So P, Q and R working together will finish one standard batch, will be able to produce one standard batch in 6 2/3 of an hour. I'm going to assign three variables. The variables P, Q, R stand for the time taken by P, Q and R working independently to produce one standard batch. So therefore, in 1 hour, the three missions respectively will produce 1 upon P, 1 upon Q and 1 upon R as a fraction of work done by them. So when they are working together, the sum of these three fractions is the fraction of work that they would have done in 1 hour. So this is the equation that we have. I'll just simplify it before we evaluate this entire equation. 6 2/3 written in an improper fraction way. This is a mixed fraction. So this is going to become 18 plus 2, 20 upon 3. We're looking at the reciprocal of 20 upon 3. So that's going to be 3 upon 20. Now look at it. What did we say we needed to find out? We needed to find out which among these three values, 1 upon P, 1 upon Q, 1 upon R, whichever is the largest, that mission is going to be the most efficient. Will we be able to determine that with this information? We have sum of three numbers equals something. We do not have any information about each of these numbers independently. So using statement 1, we will not be able to determine which among the three missions is the most efficient. Let's summarize this discussion and move on to evaluating statement 2 alone. We know the combination, the sum of three values equals a 3 upon 20. But we do not know individual values for any of these things. So we will not be able to determine which among the three, 1 by P or 1 by Q or 1 by R, which among the three is the largest of the three values. Unless we know that, we will not be able to find out which mission is the most efficient. So statement 1 alone is not sufficient. Eliminate answer options A and D. We are down to B, C or E. To determine that, let's start by evaluating statement 2 alone. 2 alone gives us the time taken by missions P and R working together. Let's not even waste any time with this. Quickly frame an equation for it. We do not have any data about Q to start with. Neither do we have information. We know the sum of two numbers is 1 by 15. Do we have individual values of these? Will we be able to determine that with this equation? No. We have two variables and one equation. We will not be able to find out individual values for each of these variables. Which means that 1, we do not have data about Q at all. Second, even with P and R, we only have the combined data. We do not have independent data. So we will not be able to determine which mission is the most efficient. So statement 2 alone is not sufficient. We were down to B, C or E after evaluating statement 1. 2 is not sufficient. Eliminate answer option B. We are down to C or E. Let's combine and see. If it's sufficient, we'll go with answer option C. If it is still not sufficient, we'll say answer option E is the one and move on. The combination basically has these two information for us, translating into two equations. The first statement gives us this equation. The second one gives us this equation. Let's do one thing for whatever it's worth before we start evaluating it. Let's plug in the value of 1 upon P plus 1 upon R as 1 by 15 into this equation. So we'll get 1 by 15. This is 1 by P plus 1 by R plus 1 by Q. This is equal to a 3 by 20. So to find the value of 1 by Q, let's take this 1 by 15 to the right hand side. So 3 by 20 minus 1 by 15. 60 is the common denominator. 3 times 3, which is equal to 9, minus 4, 5 by 60, which is equal to 1 by 12. So combining the two statements, what have we achieved? We have found out the value of one of these three parts. 1 by Q we know. Now, using this 1 by Q, will we be able to find out the values of 1 by P and 1 by R? Certainly no. So the two statements together are not sufficient is the temptation that we have right now. Because we can't find P, we can't find R, we just know the value of Q. How is it sufficient? Let's just spend one extra minute. It probably may be sufficient if you look at it properly. Is the question asking us to find out the values of P, Q, R? Or is it asking us to find out which among these three values, which among these three missions is the most efficient? Now we know 1 by Q equals 1 by 12. So we can quickly say that Q is equal to 12. Mission Q takes 12 hours to finish one standard batch. Now look at this particular statement. Statement 2. 1 by P plus 1 by R together 1 by P plus 1 by R is equal to a 1 by 15. This statement essentially means that together these two missions manage only 1/15th of the total batch, whereas Q alone manages 1/12th. 1 by 12 certainly as a fraction is greater than 1 by 15. Or if it's convenient, let's just look at it. P and R together finish one standard batch in 15 hours. Q completes one standard batch in 12 hours. Q alone takes lesser time to finish one standard batch than P and R taken together. Which means that Q is certainly more efficient than P and R taken together, let alone each mission independently. So can we determine which is the most efficient of the three missions? We did not know the values of P and R independently, but we realized that 1 by P plus 1 by R together this fraction is still a lesser number than 1 by Q, which means that 1 by Q is a larger value and Q is the most efficient of the three missions. Quickly summarize it, we'll round it up once more so we can recap this idea. What we got from these two equations solving them is the value of only one of the variables. We still, at the end of solving it, in terms of an equation, we did not have values for 1 by Q, 1 by P and 1 by R. So temptation is, without knowing 1 by P and 1 by R independently, how can we determine which among the three missions is the most efficient? But the point is, 1 by P plus 1 by R as a value, this 1 by 15, is lesser than 1 by Q. So Q alone finished 1/12th of the entire thing in an hour, entire production batch in an hour. Whereas P and R could manage to finish only 1 by 15th. Together they managed lesser amount of work than Q alone. So mission Q did more work than P and R together. Obviously it would have done more work than P or R independently taken. Without knowing whether P or R, which among the two is more efficient between them, we just wanted to figure out which is the most efficient mission. If Q did more work than P and R taken together, then Q is the most efficient mission. Together the statements have given us a conclusive answer. Choice C is the answer to the question. What is the trap that we should not have fallen into? The trap in this is, many times this question would not have taken as much time as I took to solve this. You would have looked at the first equation, 3 variables, 1 equation. You would have looked at the second statement and would have said 2 variables and 1 equation. At best, we will be able to find out the value of one of the variables. We will not be able to find out. We need 3 equations and 3 variables to be able to find out values for all of the 3 unknowns. But the trap is, you're not finding out the value for all of the 3 unknowns. That's not the question. The question is asking you to find out which among the 3 is the most efficient mission. To answer the question asked, you need not, as we realized, find out independent values. It was just sufficient the way the numbers played out in this particular example, that if you determine one number is certainly more than the other 2 independently or taken together, that would have been sufficient. That's what ended up happening in this question. Before we say goodbye, here are 2 things I want you to do. 1, sign up as a trial user at wzko.in/core. There's a topic statistics and average which is free. Take you about 6 to 8 hours to round this topic up. It's comprehensive. Use the statistics and average topic to build momentum into your GMAT preparation. If you're convinced that this teaching methodology will help you with your GMAT preparation, you can pay and unlock the remaining topics which are behind the paywall. Lastly, before you leave, subscribe to this channel, youtube.com/Wizako, and don't forget to turn on notifications. Until next time, stay safe, stay healthy, and stay motivated.